I should have known after Zach said, if you sing good tonight, you'll make it into National Honor Society, and then I sang bad at the end. I should have known that.
Okay.
I really should have known.
So this says the polar form of a complex number z equals a plus bi is given by r comma theta, where r is the square root of a squared plus b squared, and tangent of theta equals b over a. This is all the same information that we used for polar coordinates before. We're just going to apply it to complex numbers now. So in the conversions, we're going to use these pieces of information. Just like I said, this is going to look like review for you. The first piece is that our x-coordinate is equal to our real number a from the complex number, which we already know is equal to r cosine of theta. Our y-coordinate is going to be equal to our imaginary number b from the complex number, which is equal to r sine of theta. Yes, we did that yesterday. So using this information, we can actually rewrite a complex number in polar coordinates. So if I have a complex number, z equals a plus bi, I know a is equal to r cosine theta, and b is equal to r sine of theta. This is just rewriting it using polar coordinates instead of rectangular coordinates. And of course, we can simplify this even a little bit more. And it becomes r cosine theta plus sine theta I. And there's a special name for this form of a complex number, and it is the trigonometric form of a complex number. Trigonometric form. So by substituting in polar coordinate values for our rectangular coordinate values, we create a different form of a complex number.
Why do you distribute?
You don't have to pull out the r. You could leave it like this and it means the same thing.
I saw that after I said it because.
So by substituting in polar coordinates for rectangular coordinates, we create a trigonometric form of a complex number. Either one of these would be considered the trig form of this complex number. That's important. For the purposes of what we're doing today, we're going to assume that r is always positive. There's also another name for what r is, and that is called the modulus. Yes, but it also has another name. And then our angle theta is called the argument.
And the theta is argument?
Theta is argument, r is modulus. So this is just some more information in case you're ever asked what's the modulus or what's the argument, this is what it's referring to. So our distance r is our modulus, our angle theta is our argument. So now what we're going to do is we're just actually going to convert between different forms, and then we are finished.
No way.
We literally have like 3 examples left and we're done. Okay. Because it would have blown your mind.
Oh, we're about getting.
So we're going to start with polar to rectangular.
Blowing any more than it is already. She said screw here. Reminds me of one way.
Or complex. So now when I say rectangular, I want the complex number, because I know that every rectangular can be rewritten as a complex, and every complex can be rewritten as a rectangular. So when you're doing these conversions, A is equal to r cosine of theta. We've covered that before. B is equal to r sine of theta. And the example we are going to use asks us to convert a trigonometric form of a complex number in standard complex form.
You see, some of the stuff is like, not the, like, most difficult, but then when you look at it, it's like, so confusing.
I know, and that's why I'm giving you ones that look really confusing, so they're less confusing on the homework. So when we're given something like this, this is just a polar number rewritten as a complex number. So I still have the same information. I still have R, and I still have theta. What's my R value in this number? 2. We just pull it right out. R here equals 2. I know that's true because R cosine and R sine are our trig numbers. What then is my angle? Pi over 6. Look at that. We just pulled it right out of the problem. So this is no different than if I had been given the polar form or polar coordinate 2 pi over 6. They mean the same thing. This is just a different form of that point. So now what it's asking us to do is to transform this into a normal rectangular complex number. So what am I going to have to find in order to do that? Nope, I have the degree. What are the numbers in a normal complex number?
Or is it, R?
What are my numbers in a normal complex number?
Oh,
A and B. So I have to figure out what A and B are in order to make this conversion. So what is A going to equal? We wrote it above. And B is going to equal R sine theta. And all I have to do is use my unit circle and solve these out. So R cosine theta is going to be 2 times cosine of pi over 6. I know that I can find cosine of pi over 6 from my unit circle. Square root of 3 over 2. So this becomes 2 times the square root of 3 over 2, which just equals what? Square root of 3, because the 2 cancel. So my A value is going to be the square root of 3. I'm going to do the same thing then with my R sine of theta. R is still 2. Theta is still pi over 6. And I'm just going to use my unit circle again. So this becomes 2 times 1/2. And what's 2 times 1/2?
1.
So rewriting this as my standard form complex number, which is in the form z equals a plus bi, this equals square root of 3 plus 1i, which is the same as square root of 3 plus I. And that would be my final answer. So we took a trigonometric form of a complex number, pulled out the R and the theta, and then found our standard complex values, A and B, and then rewrote our complex number. Was that harder than we thought it was going to be?
No.
No. How straightforward was that? Was it okay? Not bad. So the next example we're going to do is we're going to go the opposite direction, but I'll give you a minute to finish this first. And then we're done.
Oh, yeah, 3.
I said 2 to 3.
Oh,
I'm just tripping out more times.
take it off.
Hey,
Are you not done?
no.
Oh.
Jonah's tripping.
Got it. Good for Jonah. Okay, so we're going to go from rectangular complex into polar.
Student's career. Living life.
If I'm going into polar coordinates, what do I need to have in order to write a polar coordinate?
Your R and some numbers.
R and theta, that's really all I need. So I know from the previous lesson that we did that R is going to be equal to the square root of a squared plus b squared. which is the same as x squared and y squared. And then my angle theta is going to be equal to tangent inverse
Y over.
of y over x, which is the same as b over a.
Almost.
That's good. And then I'm gonna have an example that we're gonna use.
Wait, what kind of quiz do we have in mind?
Quiz over this fun stuff.
Okay.
It'll have vectors and it'll have polar stuff. No, wait, we did vectors in the last one, didn't we? On the test. Right, so it'll just be polar, rectangular, and complex.
So the stuff we're learning right now.
So the example is we would like to write the complex number square root of 3 minus I in polar form. I know the two pieces of information I need are R and theta. Oh my gosh, there's three R's. I know. So the first one I'm going to start with is R. R is equal to the square root of my A value, square root of 3 squared, plus my B value of -1 squared. I go ahead and I square those, and I get the square root of 3 plus 1, which is the square root of 4. What's the square root of 4?
2.
2. Why am I not including -2? Because -2 squared is also 4. What did I say at the beginning?
We only take positive.
Only positive R's. So I just want positive 2 as my R. Now I need to find my angle theta. So for my angle theta, I'm going to have tangent inverse of -1 over the square root of 3. On my unit circle, that can either look like -1 over the square root of 3 or negative square root of 3 over 3. When you have it, put your finger on it.
Wait.
Put my finger on
Or
Or 2.
There are 2 of them.
I can't see them.
There are 2 of them. So what did we do before when I wasn't sure which number I was supposed to use?
Take the first.
No.
We graphed it.
We graphed it. So if I originally had this number,
So it's 30.
what quadrant would that number be in if this is my x and this is my y? Well, on a coordinate plane, square root of 3 would be positive, and then my b value is -1, so I would have gone down. So I'm looking for an angle somewhere in quadrant 4. So which one of those options is an angle from quadrant 4?
30 already.
330, which I'm going to use radians because I think it looks nicer, which is going to be 11 pi over 6. You can just put 330 if that's what you want to do. So my polar coordinate here is 11 pi over 6.
Can you go over how like you figured out at the bottom one again?
Yeah.
I kinda
Yeah,
don't know.
absolutely. So I graphed this point. Remember, we can take any complex number and change it into an xy coordinate. So square root of 3 minus I transform into the square root of 3, comma -1. Where this is my x coordinate and this is my y coordinate. So x is positive square root of 3, which would have been somewhere over here. And then -1 would have been down.
Okay.
Puts it in quadrant 4.
Wait, so
Yes.
square root of 3 is just 3.
One more time.
No, square root of 3 is 1 point something. But it was
So we're
positive. So all I cared about was that from the origin I went right, and then I went down. I don't necessarily have to know exactly what number it is.
Do we have a Newborn limit today? Or is it-
Hold on, we're not
So
done.
what was your 2
I
options?
thought we were done.
Ah, I thought this was the last example.
1, 2.
Hold on. No. So I have this polar point, correct?
Yeah.
What if I wanted to rewrite my complex number as a trigonometric form of a complex number?
Oh, there you go.
So now I would like to write the trig form of a complex number. Remember from before, my trig form of a complex number is r cosine of theta plus r sine of theta I. So then I just have to fill in the r and the theta that I got from here. And I get the the trigonometric form of a complex number to be 2 cosine 11 pi over 6 plus 2 sine 11 pi over 6 times I. Yes, ma'am.
I did the one where it's 2 parentheses cosine pi.
That's
Is that
perfectly
the same
fine.
thing?
Yeah, it just would have been this.
Yeah, that's what I did.
Either one of these are perfectly fine with me. Questions, concerns, or issues? Your homework is the same one I gave you yesterday. Now you can actually do it. Jonah, that's your final answer because this is the trig form of a complex number.
We do 5 through what?
5 through 14. Jared, what was your question?
I was gonna say, what was your 2 degrees?
I didn't pick 2 because I already knew what quadrant I was looking at. So the 2, I think 150 and 330 would have been the 2.
Yeah, first
I knew it wasn't 150 because that would have put me in quadrant 2, and I had to be in quadrant 4.
150, I figured square root of 3 over 2.
So,
Oh, that should be square root of 3 over 3.
That's
39 days and I'm not.
we did part of this in June.
And yeah,
Oh.
this was definitely a geometry thing. Okay, homework's on Canvas, get to work.
I mean, trigonometry.
Yeah.
So that's why